we can tell them about that, but you need to accept and agree that it's okay to record. So maybe to start, we could do some introductions. And I'll start since I'm talking already. I'm Brett. I live in Santa Fe, New Mexico. It's about 4 hours in a car north of Spaceport. So for me, the trip is easy. I, I,
Yeah.
I can get in my car and bring things. So I'm a level 3 flyer. I've been flying high power since 2018, and I'm the president of our local club. It's a Tripoli prefecture. It's in Albuquerque, New Mexico, and I'm the prefect there. And we have right near Albuquerque a launch site that has a waiver of 15,000 feet, like 5,000 meters. And then we have another site that's about 30 miles north of Spaceport. And we can fly to 65,000 feet there. So I have some experience flying in the same conditions that you guys will fly in. So I'm happy to share what I learned about recovering rockets in that terrain. So anyway, I'm excited to be part of your team. It looks like David is here. I'll turn it over to you guys to introduce yourselves next. How about that? David, do you want to introduce
Oh,
yourself next?
sure. I'll go ahead and hold on. My video camera's blocked. There we go.
No worries.
Um, so my name is David Abmeyer. I've been flying high power for 15, 16 years now. I fly with the Tripoli Houston in Houston. Um, I am been a TAP for Tripoli now for 5 years, I think. And I've been the LCO for Spaceport Cup for the past 3 years, and this year I'm now the Ezra VP.
Nice.
So that's my background. Oh, and just as a side note, a little bit oddly, I am a synthetic chemist by training, so my background is uh, I have a PhD in organic synthesis, and but what I made the transition a number of years ago to surface science. So my actual job is I look at surfaces, various aspects of it in the basically 50 nanometer and under regime. So extreme thin surfaces, which
Nice.
is rather fascinating.
And you're helping these guys with their rockets, so that's great.
Yep. Um, I've seen a lot over the years, having done a multi-year tour as prefect for my club, and of course now as a TAP. So
Yeah.
it's entertaining. I will turn it over to you guys.
Okay.
Uh, all about us. We are students in Turkey at Gebze Technical University. I'm a physician student. I'm Oğuz. In team, I'm a mechanical member, and my friends maybe.
My name is Kaan. I am an electronics engineering student. I am a member of the technology team. My role is avionics systems and telecommunication.
My name is Jamal. My department is computer engineering. I am also interested about avionics and mechanical things. We have been making rockets for 4 years.
I am Emre Koyakbaşı. I am electronics engineering in Gebze Technical University. My role is avionics in rocket team, our rocket team.
Great.
Eternal rocket team was founded in 2020. Then after this state, we make rockets. Then we made unmanned plane. Then now we want to come a spaceport, and we want to fly our rockets in America.
Nice. So are all four of you coming to Spaceport?
Yeah, all of us.
Yeah. And are there more people on the team coming, or just the four of you?
Yes, there are two people more.
Yep.
They are not here, but they will come with us.
Okay. So you have a little bigger team and everybody's coming.
For America, for Spaceport America, yeah, we are 6 people, but there are so much team in Eternal, like in Turkey team, for Turkey rocket team, Turkey unmanned plane team, and other competition teams. But for Iraq, for SI Cup, we are 6 people.
Okay. So before we look at your rocket, just a few logistic questions. You all have your visas now, right? Everything is good?
Yeah.
Yeah.
Okay. And do you have plane tickets and hotel reservations, and do you have a car or a van or something reserved?
Our plane tickets, yeah, we buy it and hotel Airbnb reservation in El Paso and other things. Yeah, we buy it.
We will rent a car.
Yeah,
Yeah.
and we have motor, but engine, rocket engine, but a little bit changing in motor. Yeah, we will talk about that.
Okay. So you tell me about the motor more when we review your rocket.
We will start the CSI just only M 2020 engine, but you know, just only not sell now this these motors, or nobody sell this that. And then we will look for another motors, but we already makes our bodies us the engine body, then upper body we produce it already. Then it's a bigger diameter, and the rocket was heavier. Then we want to have a strong engine. Then look for motor. When we are looking for motor, Aerotech motor thrust will less for us. Then we will change the motor diameter for then from 75 to 98. Then our motor changes. All of rocket parts can change. Then we are now producing the rockets. The last night, now, and tomorrow we are producing it. Yeah, we will talk.
Okay. So I understand more clearly. Do you have a motor
Yeah.
that will work for your flight in
Yeah.
the US? So you're sure you have a motor, correct?
Our motor in now Aerotech M1939.
Yes.
And we use it. We can use it, and we have hardware, and we are reloads from Vietnam rockets. Vietnam, you know, it's a vendor at Spaceport.
Okay. So you've contacted the vendor, and
Yeah.
they have the motor physically. Do you know if they have it, or are they waiting for it to be shipped to them?
Yeah, they can. They take it. They bring its spaceport for us. Then we bring we take it for us.
Yeah. Has that vendor received it from the manufacturer? So does
Yeah.
the vendor physically have it in
Yeah.
their warehouse right now?
Yes.
Yes.
Okay, so you've contacted your vendor and they have the motor.
Yeah. Yes.
Okay, good. All right, so please show me your rocket. maybe start at the top and, you know, show me all the pieces. I'll have some questions, but it's your chance to show me what you've done.
Okay. We are producing produce now, and our rocket's not in final now. But we are producing now. Then it is our nose cone half of nose cone. We produced it last night, and it is already mounted. We will remove after the video, after the interview. Then we are producing. We are continue to produce. Another thing is our upper body, our lower body.
Okay, so I have a question about the nose cone.
Yes.
It looks like it has a molded shoulder that goes into the body tube there, right?
It's have shoulder a much its shoulder is now smaller, but it's also more bigger with other parts. There are two rods in after here, then upper then this is a ring for here, then two rods to connect to that.
Okay, so you have an assembly that you put below the shoulder, and that is inserted into the upper body tube that you showed me.
Yes.
Is that correct?
Our last shoulder is bigger here from
Yeah.
here.
And for that joint, is it screwed together or is it glued together? What method is used to attach the nose cone to the body tube you showed me?
With shear piece.
Ah, so
Sure.
it separates at ejection.
These parts are has the upper body. Then we produce it we produce it CNC that is hard pass here, but also we use shear pins with here with
Yeah.
that.
How many shear pins do you plan and what size?
Two shear pins with but we have not we don't really decide not that we don't decide yet.
Yeah. So typically I've seen for rockets that are 6 inches in diameter, maybe 4 shear pins. So be sure that, you know, by the time you finish things, you have adequate strength and you don't end up with separation for this part of the rocket.
Okay, we make tests after this with after the production product of notebook, and we make more tests. Maybe yeah, we can use 4 shears. Thank you.
Can you show me how the recovery harness and shock card and parachute are connected to the nose cone assembly? Do you have like an eye bolt or a U-bolt, something like this?
Well, we have parachutes and we have short cords, plus shock cords in here. My friends make it now. Our parachute, we have airboats, asymmetric 8 and unsymmetric 10. And for first separation, we use asymmetric 8, and for second separation, we use asymmetric 10 airboats. Then here are parachutes.
Ah, nice.
This is the main parachute.
Here is shock cord. Maybe we
One
can.
of them.
See.
And is the shock cord nylon or some other material?
I think it is nylon, but maybe I can check. I can check it. It is
ethnic,
Flexible.
flexible, but I don't know it is material.
Okay.
No.
And will the flames from the black powder melt the shock cord? Do you have protection for it?
Yeah, we used it before. That rockets. Maybe you can.
Yeah, the one on the right, I saw, yeah.
Yeah.
Okay. And to connect to the nose cone, do you have some eye bolt or U-bolt?
Eye-bolt.
What is the hardware to connect to the nose cone?
We have eyeballs in nose cone. This is the pipe and all. This are board for here. Here that we can use it. Here it is our nose cone. We use our eyeballs.
Okay, good. All right, so you have a payload tube with a parachute below the nose cone. Can you show me that tube and what's on the other end of it?
We are not produce the payloads because of we changed our engine, and for this reason all of the production product of rockets we product payloads and
It's mess.
yeah, we decide this mess, but we are not produce it now.
Okay, so the payload is empty. There's nothing there.
Yeah.
Just wait.
Okay.
Just wait, not a special mission in. Yeah, but it's a computer like that GPS, and you can see it here. It's a Peter White so GPS. We write it report. We use it we use it for pay.
Okay. So your main tracker is located in the payload section. So is there an AV bay at the bottom of the tube? Can you show me the other end of the tube?
Okay, I can say it maybe. We have payloads, we have avionic bay, we have SAR-AD, our product avionic bay. Maybe you can see it. It is our design, and we already mounted all parts in here. It is our computer. Then with there are GPS more for body of the upper body. Then we will use the Telemega V5 for wings.
For COTS.
There
So
are
can you show me the board or the plate where the electronics are mounted? Do you have that?
no, not we have.
Can you repeat that?
Yeah. So I wanted to
See that?
see the board that you mount, or the plate that you mount the electronics on inside the rocket.
Okay, I can tell you that. There are two bulkheads for avionics, and
Okay.
you can see. Maybe I can çizgi gösterir misin?
Yeah. Okay.
Yeah, this is for a plexi plane. Then we will mount for the plexiglass plate.
Okay. So you're still working on the plate. It's not done.
Yeah, there's a basic plate.
Yeah. Okay.
We strengthen here, then we mount that.
Okay. So how will you mount the batteries? Do you have a plan for what kind of batteries you'll use and how you will mount those on the plate?
We have two avionics computer then, and we have a GPS for two computer and one GPS. Have other different batteries. We will use Lion batteries for our computers, but GPS and other computer, the Telemega, we best use little lipo batteries, like that. It's already come here, but maybe we can change it with for Leo. If you don't, if you say don't. Lipo.
I don't think that LiPo batteries are allowed in the competition. So probably you should use lithium ion batteries for all your electronics. Otherwise,
Yeah, it's another problem for us.
yeah. I think it's best to do that. So will the lithium ion batteries be cells like in a box? How are you mounting? What does the battery look like?
3D print case
Yeah.
for that.
We
We have a 3D printer, and we have designs
For putting that.
for putting that like a box. We will proceed also that it's a basic types. We will do that absolutely clearly.
And you're gonna zip tie it through the board so it doesn't move, because sometimes, you know, if you have a hard landing or if there's high G's, the batteries can move since they're heavy. So
they don't shake. It's we will mount for they don't they
For vibration.
won't, yeah, shake and orientation. Yes, stability.
so you're using black powder charges for this? Do you have charge cups? Can you show me what you plan to do with the black powder?
Okay, this is maybe you remember. This is for this is our Avionics bay bulkhead. Then there are two there are two there are two space in here. Then we will use it is our black powder case.
Okay, yeah.
And we will take it, but we use two for here. Then after other side we use two more. And maybe I can show you open rocket design, and then you will see the all rockets, and maybe it will be dark, it will be more clearly.
Yeah. So once you put in the black powder, what are you going to put on top of it to hold it inside this cup? What do you do?
In here, in test for testing we use basic paper, but for competition we don't think about that. Maybe you can say you use that for us.
So you put some like fireproof tissue in to compress the powder, and
Yeah.
and then do you put tape on the top, or how do you contain it so the black powder doesn't come out?
Tape.
This is the how do we do it? This is a waterproof and airproof tape.
Yeah.
Well,
Okay, so you put that over the top of the
yes,
black.
over.
Okay.
But we will make more tests for ejection charge
Yeah.
after the whole production. And we already
How many grams of black powder do you think you will use?
3 or more, but also we will make more tests after the whole.
Okay.
production. For these rockets, we use 3 grams for one case, and it have already one case, ejection charge case, but our now rockets diameter is bigger than, and maybe we will when test we will see it. For our calculations, 3.3 or 2, it is okay for us.
Yeah. Okay. Sounds usual. Sounds typical.
Okay. Thank you.
Okay. So can you show me the booster, the bottom part of the rocket? Do you have that ready?
Yeah, we have that. This is carbon. body, and our centerings already mounted. It's a carbon fiber body we produced our pieces. It's then we cut here for fins and our fin plates. Here we will we will after the production we will cut with laser from this plate. This is a fiberglass plate. Then we use it in here. We have our for cut forking. Then you can see this is a basic carbon fiber body. It's diameter 14.
So are the fins inserted in the slot and glued to the motor tube? So is it through the wall, or do you have brackets to hold the fins? How are the fins mounted and attached to the rocket?
With these centerings, centering motors and its mounted fins with lead iron, L iron. It's a it's mounted the fins and bana bir kağıt çekebilir misiniz? I will show. Şundan da çekelim. I will show you on before rockets. It's the same mounted.
Okay.
Yeah. It's the oldest Samsung. Yeah. Okay. It's here like that and like that and like that. Then we will use something like that. Like we use that iron and our centering like that.
All right. So the brackets hold the fins.
Yeah.
And then are you applying epoxy fillets outside
Yeah.
once you finish?
Yeah, we will use the epoxy inside and outside of the body.
Okay.
We use never fillets.
Beautiful. Okay, so you assemble with the brackets, and then when everything is together, you apply the fillets inside, outside. Okay.
We have already.
So show me your rail buttons and how will you attach them to the rocket?
There are two rail buttons in rockets, and it's it is the center of here is center of gravity, and here is our one rail button, and here is other rail button. There are two rail buttons. Yeah.
You can go here.
Or
Uh,
is rail button.
we will hold it like that.
It is mounted to centering or to this is thrusting.
I see. Okay, did you make the rail button or did you buy the rail button?
We can make it. We can already have it. You use Sigma profile, and it will use for Sigma profile.
Yeah, so you should be really careful that the rail buttons that you make actually fit the rails that are used in the competition. So some teams are actually buying 15 rail buttons and using them to be 100% sure that it works, because otherwise you bring your rocket out to the pad and the button doesn't quite fit. So that's an issue. Maybe you might consider buying some US 15 rail buttons just to be 100% sure.
Yes, this is more good.
more clearly for
Yeah.
and we will talk about for yeah. we
So,
can-
so if the rocket is on the rail, what is the distance from the base of the rocket to the first rail button? How far up is the bottom rail button?
We'll make check.
maybe I can check with. Okay, I remember. It's first rail button is 20, not 20, 70, 79. It is mounted the thoracic. Our thoracic is here. It's mounted here. Then up our motor length is 70. 73, then it is higher is 2073. The first part, and second is mounted AVX plate, AVX buttons, and it is highest. I don't remember it. Maybe I can look the operations.
Maybe we
and-
can check it on computer.
Yeah.
After.
Then second.
So my advice for you on the rail button locations is if you move them to the bottom of the rocket, say one is the bottom one is 5 centimeters from the bottom, and the other one is a meter or a meter and a half above that. There will be more effective length for the launch rail, so your rocket will be traveling faster. If you mount the rail buttons higher, when the top rail button leaves the rail,
Before.
now the rocket can float free. So you my experience is the faster you could be going before the top rail button leaves the rail, the better your rocket performs in windy conditions. So
For you,
so don't put them so high that
okay.
you
For
give up
you,
the velocity off the rail.
okay, we not that's true, and maybe we can write him.
Yeah. So I'm not telling you exactly where to go, but you know, maybe towards the bottom and 1 to 2 meters above is typical. But you in the end need to make this engineering decision and then change your simulation so that it reflects the, subtract the length, 17-foot rail less the distance to the top button. Okay.
Okay.
So can you show me how you will retain the motor inside of the rocket? Is there a cap or what's at the bottom to hold the motor in?
Okay, for the mounted motor, there are 4 elements. There are 2 elements is centering, then one element is thrusting, which we will we will mount it with screw, motor screw, or then the 4th element is maybe I can show you.
Yeah, please.
Do you know couple clip?
Say again. Did you ask a question or are you talking on your side?
Oh, that's okay. Okay. Do you know couple clip like that?
Ah, what is that?
As a couple clip, we will be
I
use.
see. So this is a clip that is.
Yeah.
I
It
get
is
it.
our last centering. Then we will mount here.
You screw those in to hold the motor.
Yeah, motor is here.
Yeah. Okay.
And not down, not
Yeah.
go down.
Yeah. And then how is the shock cord and the recovery system attached to the booster? Does it connect to the motor or does it connect to a bulk plate inside the booster tube?
Can you repeat for me again?
Yeah. So the booster of the rocket
Okay.
has a recovery harness, a shock cord that is coming up. So
Yeah.
how is the shock cord connected to the booster?
Okay. Karabina, we have airboats on bulkheads, and there are, my friends, show you.
That
Okay. So you have carabiners and a pivot,
yes,
and then there's a bulkhead with an eye bolt.
yes,
Yeah.
reliable.
Okay. And how is the bulkhead attached to the airframe?
Okay, with 6 square and asymmetric and 5 6 square.
So it screws from the outside.
Yeah, I can see you it. It is from our before rocket. You can see the
Yeah.
square. That.
Okay. So it's very strong.
Yeah. Yep.
Okay. So you have a main parachute. How big is it in diameter?
I can check it from open rockets. Maybe our motor is changed. Then
Yeah, okay. So it's like 3 meters or something like this. It's
Oh,
pretty
no.
big.
Not
Yeah.
so. It is 2 meters and 2.1 meter, I think.
Okay. So it's 2 meters. And then how big is your drogue? How large is the drogue, the small parachute?
Drag parachute is maybe you can see. You can. Our parachute bus and there is a company in here that they say we will product your parachute knuckle class and we will also wait they but our parachute it's for now.
Yeah. Okay. So either this one or another one that they can provide you, something like that.
Yeah, that is
Yeah.
our drag parachute. Maybe.
Okay. Nice.
Thank you.
Okay, great. So I thought the review was excellent. Do you have any questions for me at this point?
We don't think about that, but maybe my friends think, and I think that.
Well, you can email me if you do. David, did you want to add anything at this stage, or are you comfortable with what we've covered so far?
No, I'm comfortable with it so far. I would just, if you, I would reiterate what he said about the rail buttons. It is surprising how much trouble rail buttons are out at the pads. And it is an extremely simple thing to actually get right. And with that regard, just a comment across things in general. It is an engineering competition, but there are certain things that, in my opinion, should be off the shelf, and rail buttons are one of them. You're not inventing anything there. So get those little things right. You're going to have enough trouble with other things. Get the little things right.
Yeah. So buy some US 1515 rail buttons and use those if you can.
It's not that white.
Okay. Beautiful. All right, guys, thank you for staying up later on your Saturday. David, thanks for joining us.
Of
I look
course.
forward to
Thank you.
getting together. I'm going to submit this video so everything is complete. And I thank you for all your hard work and good luck finishing your rocket and safe
you.
travels to the US.
Thank you.
See you there.
See you in
See
June.
you.
All right, bye.